So let's have a quick look at how to use OpenFOAM to solve the above problem of using the CHT multi-region simple foam solver. So whatever OpenFOAM variants you use, you can, I think the definition files are the same, more or less. I use the OpenFOAM min GW version 2506, so we can let me to run the OpenFOAM in Windows system. So I just double click this. Now it gives me the OpenFOAM setting. So if I type foam, so it will give me the exact folder it has. So the folder is actually in the home. Sorry, in the home, and in the so this is the OpenFOAM main files that have been installed on my computer. So I will use specially a ROM folder that will store all my files, or natively I can just build a new folder called demo. So I use this, and all the tutorials I mentioned is here, and we are mainly looking at the heat transfer. So we go to the heat transfer, and the two multi-region foam, CHT multi-region foam is here, and this will be the one we will mainly use. So I just leave here, and I'll try to click here and go back to my main, and I use demo folder as my main working directory. So if I list here, and I will see the demo is exactly in the file or the folder list. So I'll go to demo. That will be my main folder for the settings. So that's only the basic knowledge of using Linux at this stage. So no any other further commands that will be needed at this situation. So let's go back to the slide. So the first, as I mentioned before, the first file system we are going to use is the system folder. So what we will do is I directly use the Windows and build a folder called system. Because we said it's Scratch, we just from scratch with the system. So the Scratch system is we need to use some initial solving or initial control of the dictionary called control_dict. So we can directly call by sum from here, and that is not relevant to any settings. It's only about the time steps and solver. So we can just copy one from here, control_dict to this system folder, and when we open it, we will see it use the CHT multi-region simple foam that is we want, and have starting time 0 and 2000, and that would be all right. That would be our setting for the current stage. And next we need to create a blockMesh dictionary. So the blockMesh, which means our problem setting, right? So if I copy this to the current folder, we will see how to build the this kind of mesh for us. So if you have some previous knowledge of OpenFOAM, so OpenFOAM is mainly a 3D solver, so it didn't use a 2D dimension, it uses 3D dimension. But at our case, we are mostly interested in the 2D. so two-dimensional settings, and we can only set some of the faces will be the empty. It's very straightforward actually, based on the dimensions to create this blockMeshDict, and you can use any kind of tools that help you, and I will use this to build that. So I will just create a new file, and I will copy this thing. And then I will explain later. So that is also part of the blockMesh dictionary. So that is. So what I'm doing here, I'll just save this as in our OpenFOAM demo system, and I change the type to blockMeshDict. So I don't need to append any extension at this stage. So make sure there's no any extension. When I go back to my system folder, so I will have the control blockMeshDict defined. So what basically I defined is depending on our dimensions. So the dimension is 200 millimeter length for the air and water and aluminum, and also different height. So the air and water region has height of 10 millimeters, and aluminum have 2 millimeter thickness. So what I do here is I use some like variables. I will try to use the millimeters, right? 200. So I need to scale it down to 1.01, which means the unit I'm going to use is meter. That's also mainly accepted in the OpenFOAM. So that is all. That is the length, that is height of water channel, and the air channel, and thickness of solid. And also we will use, as we said, it's a 3D. So we will use a unit base of 1 millimeter. And this is some extra definitions of how we say the y coordinates. So we use coordinate system like this. So the y is here and here. So we have the y0, y0, and y1, y2, and y3. So which means from 0 to 10, 12, and 2012. And we also define how much divisions we want to use. So we use mesh density. So we want to have the mesh density 1, and then we just directly have the overall sizes or overall number of divisions for each edge. And the next stage is just to define the vertices that will be used. So we define the vertices, and we'll go to the next definition of the blocks. So we have 3 blocks at this stage. So 3 blocks means we have the water block, we have the aluminum block, we have the air block. So 3 blocks. I use different coordinates, I use different vertices to have the blocks 0, 1, and 2. And the next, we will just to define the boundary. So in the block mesh, it has such advantage, which means we can directly define the boundary by the faces, right? So that will be our boundary. What it means here, if we go back to the problem setting, and we go back to the boundary. So we have the boundary defined as here. So we have the air inlet left, and air outlet right, and we have water inlet right, and we have the water outlet left. And then we have 2 walls, so 2 solid walls not solid walls, but walls to contain this fluid domain. We have a top wall and we have a bottom wall, and we don't need to define the interfaces between the solid and the fluid. So these two interfaces don't need to be defined, but we need to define the two sides of the solid. We use the solid side, so two faces for solid side. And of course, because it's three-dimensional, for the other front and the back surfaces, we define it as empty. So if you look into here, all the inlet and outlet conditions is in the patch, which means it allows the water in and out. At the top walls and border walls, which are the boundaries, solid boundaries, we use the wall, and also the solid two-side is also wall, and the front back, because we want to a 2D problem, we define it as empty. So that is the definition of the blockMeshDict I mainly defined here. So that should be all right for us to build the mesh.